Hey folks, welcome everybody. Welcome to
Hello,
the
hello.
routing. Welcome to the Routing Loop, our show about
Hello.
everything to do with AWS networking. We're back. If you have followed us before, we've been running the show weekly for the last, I think, close to 2 or 3 years on Twitch. But now we're coming to you on Twitch, YouTube, Facebook, LinkedIn. So we have a lot more platforms to get in touch and a lot more platforms to talk to you about everything to do with networking. So we're excited. For the first quarter, we're going to focus on a lot of stuff related to last year's reInvent. So we're kicking off a session today with Matt and Alex. I'll do the intros in a second, where we're going to talk about some of the new reInvent launches. But the rest of the quarter, we actually have some of the sessions that you may try to attend at reInvent, or you may actually attend it at reInvent. They're the Chalk Talks. So we have top, I think, 7 or 8 Chalk Talks that we selected. Normally at reInvent, it takes 50 to 80 people, right? There's 60,000 people attending reInvent. There's 50 or 60 of you that get a chance to experience a Chalk Talk. So we're bringing out those Chalk Talks onto Twitch, onto YouTube, onto LinkedIn, so you'll be able to join and participate and ask questions to the experts. So we're starting with a recap, but stay with us. We'll be here every Wednesday at the same time to chat with you about networking. So if you don't know me, my name is Tom Adamski. I'm a principal solution architect focusing on anything to do with networking. I've been at AWS just over 7 years, and I'm joined today by Matt and Alex. I'll let them introduce themselves. Maybe Alex, you go first.
Thank you. Thank you, Tom. Good to see you folks again. Good to be with you in 2025. I'm Alex. I'm also a Principal Networking Specialist Solutions Architect with AWS. Been here for almost 5 years now in total. Long story. But yeah, really excited to be talking to you about all things networking, especially IPv6. Don't tell anyone if you folks don't know already that I usually end up talking about IPv6 a lot. That's what you can expect this year more than probably last year. So good to see you all.
Cool.
Yeah, IPv6 isn't going anywhere, and I think you just came back from a conference where you spoke about V6 as well. So
Yeah. This year
later.
we partnered with Nanog, and we had an IPv6 clinic event at Nanog 93 in Atlanta. Nanog stands for North America Network Operators Group. Really exciting. We're gonna do a bigger event in June for World IPv6 Day. So yeah, stay tuned. There's a lot of good stuff coming in the IPv6 space and IPv6 on AWS. So yeah, it's not going anywhere. Definitely, it's increasingly being adopted. So we're here to help.
Awesome.
I've actually never been to Nanog. I used to go to OzNog, which is the Australian version. I guess it's just a lot smaller, and I don't know. It was always a fun time.
Yeah, there's. I just learned at this Nanog that there's also RONOG, which is Romanian Network Operators Group.
Oh,
and I'm originally from Romania. I didn't even know that existed. I'm like, wow, that's amazing.
So intros. I'm Matt Lewis. Some of you folks may have seen me on here before. I'm a senior principal solution architect, mouthful, in the EC2 networking team. So I still do solution architect things, but I help the EC2 networking team build the next generation of networking services in AWS. So always keen to hear feedback. And I think I really love this platform and the way we're able to present to you folks, but we love the feedback that you folks give us, because we take that to heart, and we really love thinking about, okay, well, customers are really asking for this one thing. How do we build that and make customers' lives easier? So that's kind of what I do. But glad to be back for 2025. We've got a lot of exciting sessions coming up, so
Awesome.
Should be fun.
Exciting. There's one other nog that I like. That's the eggnog.
Eggnog. it's a little early in the year for eggnog, isn't it?
It's never too late for eggnog. No. Disagree.
100%.
All right. Cool. I'll let you guys take the stage. We only have an hour. So last year we had an hour and a half, so we were kind of loosey-goosey with our timing. I think this time we got to be sharper, but pop in your questions in the chat. If you want us to dive deeper into anything, there's slides. We also have a whiteboard. Every once in a while, we'll also bring a demo as well, depending on the session. So yeah, let's keep it interactive and throw in questions as we go through it.
Yeah, and it's super exciting because I already see some of the old friends of the show. Ken, Dominic, good to see you folks. Really happy to have you back. I also see a lot of new folks. So I super excited that we have now a broader platform to get all these cool things in the networking space closer to you. So yeah, let's get things started. We're doing the reInvent recap, right? Matt, do you wanna take
us in? So I do want to admit something embarrassing. The background image that you see here, the 3D vector, took me probably about 45 hours to create, and we used it for about 2 seconds on stage. So I'm glad it's getting more use. But the prologue is basically where we would dive into what's happened over the last year up until the previous reInvent. So how things are put together. Now, this slide here is basically, we've tried to imbue all of the AWS networking features, functions, services into one architecture. Now, we do have a QR code coming up, which is a link to our session where you can dive into what it looked like previously. But if we just want to jump back real quick, Alex, you can see that basically the VPC is a center point for everything that you do in AWS, right? And all of these other services and features and functions really sit inside or outside or attached to the VPC. Now, I think I counted about 25 different features that we have on our list here to roll through. So let's keep going and let's dive into the first one, Alex.
This chart is always a nightmare. Every time you start, Matt, with your sessions, it's always that one chart that encompasses all of the services we have, and you're looking at it going, oh boy.
Yeah.
Well, the problem is every year we try and turf stuff out of there because we need to make room for the new stuff. But yeah, sorry, Alex, you were going to say something.
So for everyone who hasn't seen our session yet, here's the QR code that takes you to the session and the short link. It's on YouTube. The intro is Matt thing every year, and as you get all this build up and then you show the full picture of it, I can't stop but feeling this sense of, wow, this is amazing. There's so many cool things you could do with all these services. So yeah, I think starting with where we've started at the beginning of the year and ending, you folks will see with where we are at the end of 2024 and getting ready for 2025 is really exciting. I love this kind of setup. I think it starts us up for cool things that it can do and build. So yeah. If you folks have seen the session, you know that we're kind of splitting our content into chapters. We usually start with the foundations, and the foundations of any network are IP addresses and IPv4 addresses, IPv6 addresses, and IP address management. So Amazon VPC IP Address Manager is our core IP management service on AWS. It's essentially built to help you not maintain IP addresses in spreadsheets. Hopefully, you're not still doing that. It's really easy to use, and in 2024, we've added more features to it. We now allow bring your own IP addresses from IP registers, registered IPs registered with any internet registry. Does anyone know what an internet registry is, by the way? Let us know in the chat. I see a lot of new folks.
You register your IP addresses there.
Very close to it. They're the bodies, global bodies that are governed by IANA, which is Internet Assigned Numbers Association, which are actually assigning IP addresses in addition to other numbers, for example, like public autonomous system numbers, to organizations. So if you ever want an IPv4 address or an IPv6 address block, you would essentially go to an internet registry and get that in the region where you are. Now, very cool thing about IPAM is that you don't need to go to an internet registry. You can also use Amazon assigned IP addresses.
So can you still get IPv4? Yeah, can you still get IPv4 addresses from the registrars? I thought they were already depleted, no? And all that's left is V6 now?
That was some time ago, right?
They ended in, I think the last one that got assigned was Aaron, America, internet registry. And it got assigned, I want to say 2014 or 2015. So quite a long time ago. But really important to get one, to get blocks now, you have to go on a wait list. Last I checked, I think requests in ARIN at least were processed now that were made last year in like October. And you can't go about request any size. Like there's a lot of justification that goes with requesting sizes that are bigger than /24, for example. So it's a tough process. That's why IPv6 is so important.
And I got a question, Alex. Oh, sorry, you might go for it.
I was just going to say real quick, I think your 2014 timeline's pretty spot on. I saw a presentation at OSNOG, just to link back to that, by Jeff Houston. It was titled The Four Horsemen of the Internet Apocalypse, I think. And he had this graph where the IPs that were available to be assigned were like slowly depleting. And at I think 2014, they would disappear and the internet would burn to the ground. It didn't. We still have IPs and things are still working. But
there's a lot of transfers and recuperation of IPs and so on. Before we move a bit further, I want to say hi to everyone who's joining us from all corners of the world. This is so exciting. I see people here from Germany, from India, from South Africa. This is amazing. Thank you, folks, for joining us. And I'm really excited to see that you folks are interested in networking and content delivery. I always feel like networking is not kind of like the top topic that everyone's talking about. It's not like Gen AI these days. So really, really happy to see you folks joining.
But so it might not be the top topic, but it is the foundation of everything that we do. It's built into everything. Go ahead, Tom.
Yeah. So the question I had, maybe Alex, you want to explain why would I want to bring my own IP space into AWS, right? So AWS gives me public IP addresses to assign to things that I want to expose to the internet. Why would I need to bring my own range? What's the benefit I'm getting?
There's a couple of them. I would say that probably the majority of organizations and enterprises that deploy their resources and workloads on AWS don't need bring your own IP. You can absolutely come and get them from AWS. And now with the contiguous IPv4 blocks that you can get assigned from the Amazon pools, you can do easy summarization. So all challenges solved. Now, the reasons why you would want to do it are twofold. First, if you do bring your own IP, you get control over the advertisement status. So if that block gets advertised to the internet from AWS or not, you have a toggle there that says this is advertised or withdrawn from AWS. So you get control. For the Amazon provided blocks, you don't get that control. Those blocks are advertised on the internet and they are present in the internet route table. And that's about it. The second reason would be IP reputation. Depending on your workload, we have, for example, let's think of an email sending infrastructure. If your workload essentially sends emails to a lot of inboxes for campaigns, for things that you want, like maybe newsletters and things like that, there is an IP reputation associated with IP addresses. So spam filters take on those IP reputation data points, and they're like, oh, this email comes from this IP address. Maybe I don't have reputation information about it, so I'm going to filter it out. Given that the business logic and the business function actually relies on that reputation and on that email not being filtered, here's where some of our customers choose to use their own addresses that they carefully curate and control reputation for.
Gotcha.
I think there's an interesting scenario with some CDN providers out on the internet where they have a checkbox that would say, or they used to when I was looking into this issue, a checkbox that says block EC2 public ranges. And what that means is anything that's hosted inside that CDN providers or on that CDN is not allowed to be reached from EC2. Now, it's normally not a problem if EC2 is predominantly you request something from an EC2 instance and you get a response. But there are architectures now, and particularly some telcos that actually run on EC2 that send their traffic from EC2 instances. And so they can't actually reach those sites because they're blocking the EC2 ranges. So when you bring your own IP, you're basically saying, hey, and bring your own ASN as well, saying, hey, these are actually mine, and I have a better reputation than maybe a different EC2 instance that may be blocked, or a different reputation, let's say that.
I do want to share, though, that we have at AWS a team that deals with all IP management, acquisitions, and distribution of IP addresses within Amazon and for AWS services. And this team is working on making sure that that reputation is maintained, also for Amazon IP addresses. So unless you have very niche corner cases and very specific requirements, Amazon provided contiguous blocks would meet your needs.
I think we do need to keep rolling. We're on
Yep.
one of about 25, and we're 15 minutes into our 60 minutes here.
Yep, absolutely. Super interesting feature. IPAM, by default, when you enable advanced here, it discovers your entire organization, AWS organization footprint. All IP addresses that are assigned, it's providing you with information on if those IPs are overlapping, if they're managed, if they're not managed. So you get the full view and the full picture. Now, this works a lot for customers who operate in very straightforward organizations. But we've discovered that as it happens with mergers and acquisitions and organizations that grow and evolve, the IP management conversation is more of a political thing rather than just an IP management networking concept. So we've heard feedback from customers where they said, well, certain organization units in my organization should not be managed by me in IPAM, should not be centralized or centrally managed, and IP addresses in those organization units should be excluded from IPAM. So now you can, after the launch of reInvent, you can exclude certain OUs from your organization so that you can essentially not manage those IPs. Careful, though, with this, because if those environments get connectivity to your network and then they have IP addresses that are overlapping, you may not have a very good day. So use this feature wisely, I would say.
Hey, Alex, we have a question here from Karim El Jamali, kind of related to broader kind of IPAM. So maybe not specifically to this feature, but in general, from a management perspective, how should you think about IPAM? Is it a regional construct, global? How does that work?
Yes, so VPC is a regional construct, and IPAM is a global service. When you create your IPAM, you create it in a region, for sure. That's where essentially your control plane exists, and where you go in and you make changes to the pool structure, to your IP assignment policies, and so on. But in IPAM, your pool structure, the way IPAM discovers your environment and tracks and monitors IP addresses in your organization is globally. So if you have resources in multiple regions, you would go in IPAM and you would say, I want you to manage all my IP space in these regions. And you get to choose which regions you want to manage in IPAM. And IPAM automatically tracks and monitors all those IP addresses globally. And this is absolutely making sense because an IP addressing plan is a global kind of construct. You're not building usually an IP addressing plan just for a region, completely ignoring all the rest of your environment. So really important.
Cool, thanks.
Yep. And of course, because we could not go about talking about IP address management on AWS without touching on IPv6. There's a lot of launches that happened in 2024. There will be many more upcoming in 2025. We can't talk roadmap, but stay tuned. 20 plus IPv6 support service announcements in 2024. We've launched VPC private IPv6 addressing. So now you can use ULA, unique local addresses, in IPv6 in your VPCs. Pretty specific use cases for those. So if you folks are interested, we have a blog post that describes how you should think about IPv6 addressing on AWS so that you can create scalable addressing plans. And I think this is my favorite feature. EC2 Instance Connect supports IPv6. And do you guys want to guess why this is my favorite feature?
I mean, EC2 Instance Connect used to consume a public IP when you would have to spin it up, which is a waste of a public resource, especially considering those resources cost you money.
Exactly. That's one. And two, probably the first thing that I would do, I don't know if everyone does this, but when I deploy an EC2 instance or I configure something and I want to test it out, the first thing that I would think about doing is SSHing into my test instance. And to SSH into the instance, I have to manage the keys and I have to make sure that those keys don't get leaked. And doing this in a testing environment, like in my own account, perfectly fine. But if you're doing this in a production environment and you want to have access, like operator access, having this fully managed through Instance Connect using services like Session Manager is really, really important because you don't want to be managing SSH keys. Those are in themselves a security concern, I would say, not to just say risk directly. So really, really important. You don't need that for EC2 Instance Connect, and you no longer consume public IPv4 addresses to SSH into your, to connect into your instances. So really awesome feature release. Now, here we go. Matt, do you wanna take us through the security foundations and new releases?
Let's talk about the security foundations here. So basically, within a VPC, there's two main mechanisms that folks are using to secure their EC2 instances. So one would be a network ACL that basically is assigned to a subnet, and then there's a security group which is assigned to an EC2 instance. Now, folks are using things like firewalls within a VPC. I think we've got some stuff coming up on that. But yeah, let's keep going. We have a bunch of security group features that we launched this year. The first one here is security group associations. Alex, you want to talk through how this one works?
Yep. So by default, when you create a security group, that security group is created within an account and within a VPC. Now, if you have, for example, multiple VPCs in the same account in a region, and you want consistent security group rules, you would have to create one security group with the same rules in 3 different VPCs. So this is what this feature comes to make it easy for you to define a single security group with the rules that you need that security group to be configured with, and then take that security group and associate it with multiple VPCs in your account and region, which means that after association, workloads in those VPCs can use the security group that has been associated with their VPC, and then they can benefit from the consistent security group rules that you're configuring there. So super important feature to ease the management of security groups across multiple VPCs in the same account.
I think the same account callout is probably quite important here,
Yes.
right? So if your strategy is have one VPC per account, right? So I have 10 VPCs and I will have each one in its own account, then I really wouldn't be using the VPC associations because it's account bound.
Yes, it is account bound, and here is where we go towards the security group sharing piece. One of the ways in which customers choose to grow their footprint on AWS is by creating multiple VPCs, right? So multi-account, multi-VPC strategies are, I think at this point, table stakes for any deployment that scale on AWS. Now, when you scale to multiple accounts and you want to kind of provide this managed networking environment to these application accounts that get their workloads deployed on AWS, you can use VPC sharing. So VPC sharing, essentially, exactly as its name states, means that an account manages the VPC and the networking constructs in the VPC and shares subnets with participant accounts. And these participant accounts can come in, deploy their workloads in the shared VPC, and not care about networking. Well, all good and nice, but there was a gap. You, as an application owner, as a participant account, you got your subnet, but you weren't getting the security groups that you should be using. You had to define your own security groups. You had to manage them independently. And oftentimes, a lot of customers were sharing that it's really hard to maintain these standardized. So with security groups sharing, you can, as a VPC owner, as a shared VPC owner, you get to not only share subnets with your participant accounts, but also share security groups. So you can define a security group with consistent rules that are approved by your security policies and dictate how traffic should flow in and out of certain resources. And then you can share these security groups with participant accounts in the VPC. And these participant accounts can take these security groups and associate them with their workloads. So really straightforward and awesome, I would say.
Yeah. So, but it sounds like so I can share security groups across accounts, but only if it's within the VPC that those accounts live in. So I think
Yes.
there's like this third use case that I chatted with a few customers where I assumed, oh, Amazon's launching sharing of security groups. I can have a security group in account A, just give it to everybody everywhere else. It's not the case, right? If it works, you can share the security group if you're in the same set of accounts between different VPCs. Or if you want to switch between accounts, it has to be the same VPC. So there's always like a little bit of a boundary that you need to think about.
Yes. So we don't support a security group that is being shared and used across multiple VPCs, across multiple accounts. But your feedback is really important. So let us know what you think about that, if it would be something that you would be using. I
Question
see
here
we
from
have questions.
Nismurf, Alex.
Yeah. So if security groups are shared, is it change in one place and everyone gets the update? Yes. So to change the security groups, only the security group owner can do that. So you would go in as an admin, as a VPC owner, as a security group owner, and update the security group rules, and those get automatically applied to all resources that have that security group in use. I think another super important piece here is that you, as a resource owner, you can choose to use, in addition to the shared security group, your own security group, because you may want to define different levels of filtering. So you can say, well, this is the enterprise defined security group that has been shared with me, and it does more of a coarse grain filtering at the enterprise level. And then I have my own individual security group that I've configured for my database, and that I'm going to allow just app 1 and app 2 to access me. And that is controlled by me as a workload owner. So really important.
Okay. So we're on number 5 of 25 with 30 minutes consumed.
I think you guys
We're
just need
getting
to
there.
pick. You guys need to pick what do you think is going to be more valuable to share. You're going to have to do like a hard decision.
We might have
and
to
say,
skip over a couple here. Yeah, I think I can talk about this one real quick. So VPC block public access. So if you want to go to the next slide, Alex, thank you. So basically here we were hearing from customers that they wanted a blunt tool to say, hey, this VPC should not have any internet access. And that's what block public access basically is. So very rudimentary. It took us a while to build, but a super simple switch that you can say, hey, block public access. And that's about it. Let's go to the next one.
Wait.
Yeah.
No. Let's talk about it.
One down, 24 to go.
No. Let's talk about it. These are cool things, and I think we want to spend some time on, because you're showing me there's an internet gateway, there's an egress only internet gateway. So does the feature work? Say I have a public subnet, I configured a route in that subnet, I have an internet gateway. So ultimately, I build everything I need to build to be able to talk to and from an internet. And then you're saying if I switch the switch on and say block public access, whatever I build doesn't matter. The VPC is not getting access to the internet.
Exactly.
Yeah.
Cool.
I think that the key was, and people might say, well, that seems silly. You've got an internet gateway, you want internet access, but the truth is you might have different teams managing different things, or you might have a compliance team saying, hey, actually, this applicant, because we deploy this application, this VPC, we really need to block internet access, regardless of what's going on. Right. So there needed to be a tertiary mechanism there, I guess tertiary, to say, hey, no access. We can tick this checkbox now, and we know that that's the case.
And it can
And
be
I
applied
think
as a centralized policy, right? So
yes.
you can say, hey, I have all the VPCs within my organization or with a particular tag. How do we define kind of how do we apply those rules?
So that's where it's super important, because in large scale organizations, you may not always have control over what VPC owners do. So here's where you can say, well, in this organization unit, folks, you don't get to have internet access because I don't know, certain PCI compliance requirements say that. You can go and you can set that at the organization unit level or even at the organization level. And no matter what the VPC owners do and whatever they configure there, this gets enforced. You can exclude certain resources, so you can exclude accounts, you can exclude VPCs, and you can also do subnet level exclusions, which is really important. And it helps a lot for customers to build those kind of DMZ architectures without thinking that they need a separate VPC, which was a really common scenario. They were like, oh, this is my DMZ VPC and this is my workload VPC. Your DMZ are those subnets in the VPC that get access to the internet, and the subnets that are completely private and don't get to have access to the internet can be configured with block public access.
There's a good
and
discussion. Sorry, go on, Alex. Sorry.
Last but not least, I see that there's a question there. How clear is, for Kareem Jamali, how clear it is to see it across all pages that the VPC doesn't have public access? Visually is really cool because you can see it in the console in the VPC definition. You get now a new column that says block public access, and it says block public access disabled per VPC. You get that per subnets. So really, really easy and intuitive to see it if you're using the console. And of course, you're going to get it into all your API calls for describing VPCs and subnets.
It's a good question because you can imagine someone like spinning their wheels troubleshooting what's going on and then realizing that the org has block public access enabled.
Yeah.
Hiding behind the question there, Tom.
Yeah.
Hey, I do want to call out a couple of things. It can be bidirectional or ingress only. And if you are using a local zone, we don't actually support block public access in a local zone. We don't have things like NAT gateways and transit gateways and some other hyperplane-based services in local zones. So block public access isn't enabled there.
And there's a few other questions here. So Dominic, which I also really like this question because we build these architectures where today you might not need to have an internet gateway, but then you're sending all your traffic somewhere else, and then you're breaking out to the internet from another VPC or even from on-premise.
I would say that this is your choice. Block public access doesn't know that, hey, you're going through a transit gateway to actually go to an internet egress point, for example. So yes, you can absolutely have your default route to the transit gateway. That is private component from our perspective. Like if you get internet access through it, that's your configuration, that's your design decision. So yeah, you don't get, we don't drop up, but block public access does not drop those packets because we would think that they are intended to go to the internet.
So ultimately, block public access is literally blocking public access for the VPC that's enabled on. But if you created a default route and a route to the internet through a different way, so like transit gateway back to on-premise, and I have my own internet breakout that I'm managing, or transit gateway and then another VPC that doesn't have block public access enabled, I can still use that path to get out. So it's not going to completely limit that access, but basically is saying, hey, you won't be able to get out of directly through this VPC anymore.
Exactly.
I think the key thing to think about is the internet accessed on a VPC, the IGW, is controlled by AWS. It's almost like a managed service. It is a managed service, it's managed internet attached to the VPC. There would be no way for us to know, there are ways, but there's no way for us to know from a VPC that going out of a transit gateway over a direct connect would end up in the public internet. And so it's not a compliance mechanism to say, hey, absolutely no routing to the internet in no means possible. It's just, hey, using this AWS managed service that's the internet gateway, we're blocking public access. And I'm just thinking, maybe that's a feature request to say block public access could do some kind of routing path follow to a public endpoint. And if there is access, it could figure out how that is and then block that. So maybe, Dominic, you're onto something. So we'll take note of that.
Yeah.
Cool. Very cool. All right, I'm done with questions. I know there's a few still in there, but I think we can crack on.
Yeah. Let's go further, because there's exciting features that we've launched, and I think we would want to spend a lot of time on each and every one of them, but just at least review them. So security group referencing. This is a feature that so many of our customers love. And we used to support it only across intra-region VPC peering, and of course within the same VPC. Probably one of the top asks on Transit Gateway for a few years, and we now support it. So you can use security group referencing across VPCs that are attached to the same Transit Gateway. The really important call out here is that it supports in inbound rules. So you can use security group referencing, reference other security groups and attached VPCs in your inbound rules in the security group, not in your outbound rules. So really, really cool. Facilitates migration from VPC peering, where you have security group references. If you have egress security group references, by the way, and you want to migrate to this, you can just translate those egress ones into ingress ones on the destination, essentially, and work around the egress limitation.
I would actually say, I feel like this is a bread and butter feature we should have launched with Transit Gateway on day one. I know why we didn't do it. You could do security group referencing. You can do security group referencing across peering. But what we're actually doing is we've got a shared memory space across the VPCs. And then we get back into the conversation, which Alex, you and I have had many, many times around VPC size, in that you basically have a shared domain across peered VPCs. The reason why we didn't do it with Transit Gateway from day one is we wanted TGW to be a segmentation mechanism. And so you wouldn't have a shared memory space across those VPCs as far as VPC size is concerned. So it took a long time to build this one. And I know the development hours that went into it. And so, for such a simple feature, I'm pretty proud that we were able to pull this one off for sure.
Yeah. One more thing that I forgot to say with the block public access. You can see it in Network Access Analyzer. To the question earlier, like, is it easy for you to see if it's enabled or not? You will see it there. It's going to be set as an output. So super important. Now let's see. Cloud One.
Do we have a slide, sorry, Alex, to introduce Cloud One a little bit, maybe before we jump into features?
Yeah,
we might have deleted that one in the interest of time, but
this is the we have two slides for Cloud One. So we have this one, which is essentially listing the three main features or reasons why you would choose Cloud One, right? So it's intent-driven global connectivity using the AWS backbone. Think of your transit gateways, but with added features and fully managed. So you just get to say, this is what I want my global network to look like. These are my segments that are global. I'm attaching my workloads to these segments, and I get this global connectivity seamless without me having to put a bunch of static routes in transit gateways. Just by simply specifying my intent into a policy. It's a JSON policy. Once you apply it, everything gets automatically built. Given that you have this global segmentation paradigm that's based on intent, you will see that in Cloud One, you everything you do, everything you configure is through this policy. So bullet point number 2 here says unified network segmentation and traffic inspection. A lot of customers have the use case of coarse grain segmentation between segments, right? And filtering and saying, well, I want, for example, traffic between my prod and dev, or between my non-prod and prod to be inspected using firewall solutions like AWS Network Firewall or third-party appliances. That becomes really, really easy with Cloud One, and we're going to talk a bit about service insertion in a second. And you now get your one-stop shop for monitoring and managing your global network. So you go into Network Manager, and you have there all the information related to events, routes in your Cloud One core network, attachments, global topology view. I really like that view. I think it's really intuitive from how it looks like, and yeah, it's essentially your one-stop shop global connectivity option on AWS.
I
I
have some messaging. I don't think it's officially approved, but I like to call Cloud One as like a bunch of transit gateways in a trench coat. So under the hood, right? We don't officially.
We should try and get that one approved.
Yeah, I think that's a fair assessment, right? If you're familiar with transit gateways, but you have to manage them regionally, put them in a trench coat, stretch them globally, and you have Cloud One. Manage it centrally, and add a bunch of nice bells and whistles automation, and you have Cloud One.
Yeah,
I think one of the challenges that I've heard from customers with Cloud One is that when we built Transit Gateway, we tried to stick to routing constructs as much as possible. And people say, is that just the router under the hood? It's not. It's a massively scalable service, but it has the same kind of functionality. Cloud WAN really removes that layer of complexity. And so if you're starting and you come from a routing world, you might say, oh, well, Cloud WAN has new stuff to learn. But really, once you get over that little hump, I think Cloud WAN's a far easier and better product to use to go global across many regions than what you would have to build with Transit Gateways, because we do it all for you.
Yep. And it's essentially simplifying your global network. I know if you're like a hardcore network engineer at heart and you want to see your BGP sessions and you want to manage everything and you want to be the one who's putting the static routes there, you could absolutely use Transit Gateway, and you will get global connectivity with it too. But if you just want to say, I'm defining my policy and everything needs to talk to everything in this global segment, and between segments, I'm going to add my firewalls and this is inspection, Cloud One is for you. You don't have to build things around it to manage it, and you don't have to actually know a lot of BGP or routing protocols or physical networking constructs, I would say.
Okay, I'm scared of the clock here, looking at how many we have.
So,
but let's keep going.
Cloud One had supported to begin with 5 attachment types, and at reInvent we released the 6th one, which was really, really, really waited for. It now supports Direct Connect Gateway attachment. So you can essentially attach your Direct Connect gateways that connect you to your on-premises environment to your Cloud One core network edge in every region. You can select which regions you want the DX gateways to be attached to. You can, by default, attach it to all the regions in your core network. You can configure routing. We have a very detailed blog with routing scenarios for global networks, global segmentation. So yeah, really, really exciting. I think it's a really big milestone for Cloud One. And yeah, to Dominic's point, top 5 feature asks. I think yes, for sure.
I think starting with Cloud WAN and then saying I've got Direct Connect and you've got to go back and use Transit Gateway just seems like not the right situation. So this is great. Yeah. Now you don't need to do that.
Exactly. And because we mentioned service insertion, which is that managed feature that allows you to inspect traffic between your segments, Cloud One came with a new component, which is called a network function group. Under the hood, it's actually a segment, but it's fully managed by Cloud One. And it allows you to simply describe through the policy, I want to inspect traffic between network segment A and network segment B, or I want to inspect traffic between network segment A and the internet. So we allow 2 inspection patterns, centralized internet egress and cross-segment inspection. We used to call it East-West. A lot of customers have told me, wait, is it like US East and US West? Like, no, East-West as in segment to segment. So keep that in mind.
Just following the chat here, there was a question from Ken around PBR. There's already a PFR on that one. So we don't talk about future states here, but there's definitely that request has been tracked. So yeah, add more detail in the chat if you'd like to as well too.
Yeah. And I see Dominic here is waiting impatiently for us to get to the application networking piece and accessing VPC resources through private link. Here we go. Application networking is, I would say, an umbrella for a few services on the AWS side that try to bridge that historic gap between application teams and network teams, and network teams not knowing what application teams are doing, and application teams saying, oh, networking is hard and I don't want to do it. So we have a few services in the space of application networking. The forefront of this category is VPC Lattice, and we're going to get to it in a second, but let's start with application load balancers. A lot of features were released in 2024. I will double down on one, which is really important. V6 only support for internet-facing or for public-facing load balancers. Really good option for you to optimize on your public IPv4 address use. And the one-click integration with CloudFront and WAF, web application filtering. So really important.
I want to highlight another one in there, the capacity unit reservation. I think it's specifically important for very big customers, right? Because what we used to happen is the way load balancer scales is, as long as you're kind of growing at a regular rate, I think it's like less than 100%, whereas they double in 5-minute period. So if you double or less in 5-minute period, load balancer is going to catch up. But if you have like a huge spike of traffic, it's going to take a while to catch up to your load. So customers had to like contact support and request, hey, can you guys scale the load balancer for me? I'm expecting a spike of traffic. Now we have an API, so you can go in yourself and say, hey, scale this for me to massive state. I know when my peak is going to happen, so you don't have to rely on support cases and having to track it yourself. It's just an API call.
Yep. And you folks are going to see that network load balancer, our TCP, UDP, TLS load balancer, kind of closely matches the ALB functionality in these launched features. So again, one-click integrations are big. So CloudWatch Internet Monitor is the one we've launched in 2024. Zonal shift, zonal auto shift. Really critical for resiliency and resilient workloads and maintaining that. So really exciting news. I'm going to go a bit faster through API Gateway. I think, Tom, yes. Thank you, Matt. I see I have the big red timer here in front of me. So I think the panic intensifying is a very interesting feeling. For API Gateway, I want to call out one super important thing, which might have gone missed in the documentation, which is IPv6 support with private custom domains. Private custom domains was a feature that a lot of our customers have asked for APIs. So essentially configuring custom domains for private APIs. Now you can do that. And in addition to that, you can also add IPv6 support to them. So you can make them dual stack. Very exciting. And we get to private link. Dominic, exactly where you wanted us to get to. I won't spend time on talking about what private link is. I think we do a pretty good job at having a lot of sessions and a lot of talks that do talk about this. But if you folks are interested, leave us a comment in the chat and we can share some documentation on our pages.
I think with private link, and this goes for any of the sessions or any of the services that we're talking about here, if you'd like to have a deep dive session on any of these, post it in the chat and we'll add it to our agenda for this year. We'd love to do a deep dive on private link. The one sentence description of private link is really building services within a VPC. It's one mechanism, and dropping those privately into another VPC. Now we've used that same technology for a whole bunch of different services in AWS to get them privately into your VPC. Let's keep going, Alex.
So Private Link historically supported TCP and TLS services, and now it supports UDP services. It was such a big ask for Private Link, so now you can have your resources that are exposed, have UDP listeners essentially on your load balancers, and create Private Link endpoints for those. They are dual stack, so keep that in mind. And your target for the service needs to know IPv6. This is a really, really big one. Now, another service type that's supported, VPC resources. So for those types of resources that you deploy in your VPCs that are not necessarily load balanceable, so you can't put a network load balancer, an application load balancer in front of them to get them integrated with Private Link. Here's where Private Link support for VPC resources comes in really, really handy. So it's essentially a one-to-one NAT. Think of it that way, where on the client side, every single resource that you expose to a resource configuration gets mapped to an IP address in the client VPC. So no need for load balancers. Now we have
the key piece of feedback here was, hey, I love Private Link, but I don't need an NLB for this service that I need to exist privately over there. And we didn't have the mechanism to have a Private Link needs a load balancer, needs a network load balancer there. So now resource endpoints do not. Keep going.
Exactly. And to define these resources, you can do it in 3 ways. ARN based, AWS resource name. That works for RDS databases for now. DNS name, so any publicly resolvable domain name system name works, and IP based. So if you have a resource that has an IP address and you want to expose it, and the only thing that you know about that resource is its IP address, you can absolutely do that. We're gonna step further a bit here with.
I think we're halfway there.
Yeah.
Well, actually, a bit further than halfway.
Almost. We are. I think we're going to do great. Cross-region support for Private Link endpoints, really big. The things that you were used to using inside the same region with a VPC endpoint and access to a load balanced type of Private Link service. Now you can deploy these endpoints across multiple regions. I think the most important call out here is that it works with your existing services. You don't have to recreate your endpoints. If you go on your existing endpoint service and you edit the regions where that is available, you will automatically get the capability of creating VPC endpoints in those remote regions. Really exciting.
One of the things I'd love to understand a little bit further, and maybe we can have some interactive whiteboarding sessions this year to talk about this kind of stuff, is where you folks are building unnatural things to build things like unnatural architectures. And with that one, it was folks were using VPC peering to connect 2 VPCs together and to connect to a Private Link endpoint that existed in another region. We're like, well, hey, we can just flip a switch and make it available. Would that be better? And it is. All right, let's keep going.
VPC Lattice, one of my favorite services on AWS. I think it's a truly game changer for how enterprises and customers do networking on AWS and application networking. We won't dive too deep into it, but it now supports native ECS and ECS Fargate integration or built-in integration. Your tasks, they no longer require application load balancer in front of them. Directly a VPC Lattice target group, it works. So no need for load balancers in between. Service types, again, it initially was launched with HTTP and HTTPS support. Now it supports TLS listeners, so you can do MTLS cross Lattice if you want to. We have a lot of customers who've shared that use case. Where Lattice is not in the authentication path anymore. And very, very awesome support for VPC resources, which is the same feature that Private Link supports. And now you can use it in VPC Lattice at scale for a lot of clients that need to access resources. Instead of dropping a VPC endpoint for every single resource that you create across every single VPC that needs it, You just associate that resource configuration with the VPC Lattice service network, and all clients associated to that service network can access it, which is amazing. I personally love it.
And I just want to say, based on VPC Lattice, if you folks want to let us know your favorite service in the chat, that would be awesome.
Yep.
That was a joke.
So service networks in VPC Lattice with service network association, that could be accessed only from the VPC that was associated to the service network. Now you can access the service network from other VPCs or from on-prem or from a cross-transit gateway, for example, using the service network endpoint. Really exciting, very important feature ask that our customers have shared with us. And I think we're getting to the last chapter here. We're not going to go into the monitoring piece, but let's recap Zero Trust User Access. Here's where AWS Verified Access is our VPN-less remote user access service that allows really granular access to your applications. Now, again, you folks kind of see the trend here. We started with HTTP, HTTPS, but not all applications are as such. So non-HTTPS applications were critical for customers. So we now support it. You can provide access through AVA to TCP applications, port protocol, essentially, or to ephemeral resources. Really cool. Won't dive into these ones. And Edge application delivery, absolutely. Dominic, CloudFront VPC Origins is here. A few launches for CloudFront in 2024 that are really exciting. And I think there was a question a bit earlier with private VPC Origins. Someone asked if you could use this in conjunction with VPC Block Public Access. Really exciting. So yes, I highly recommend you look at these. Your load balancers don't need to be public anymore. They're private completely. So no public IPv4 addresses, for example, that are being used. And yeah, that's about it. The last piece in the observability space, instance-based monitoring, infrastructure performance. These are services that have been there for a while. In Internet Monitor, we've launched a few features that were really asked for by customers. Internet outage weather map is really exciting. I highly recommend you folks go in and look at it. Really, really exciting. And for Network Monitor and Flow Monitor, which is a new service, highly recommend you folks check it out. It's awesome to troubleshoot packet loss or increased latency from the host level. So
I think just a couple of words on monitoring and visibility. I think that's something that we're working on over here. And CloudWatch Flow Monitor is a step in the right direction for us. And having agents available that are deployed within the AWS Army to be able to give additional visibility is something that our customers have been asking for a long time. So I think we're going to be doing a lot more in this space. I think this is, I'm pretty excited by the steps in the right direction here. I noticed in the chat before there was some comments about visibility and observability too. Yeah. So I think it's something that customers want.
Yeah, I've shared links. I think probably time to wrap up because we only have a minute left. But I've shared links for the routing loop. So we have upcoming sessions that will be effectively the best sessions we had, the best chalk talks we had at reInvent related to networking. So there will be an observability session. There will be a session on Lattice. So all of these topics we'll probably have a lot more time to spend on. I think this was like a whirlwind of everything that launched, and sharing a lot of things in one hour. So
before we get cut off, I do want to say that Alex and I created all of these slides for reInvent. We choose a theme every year. This one was kind of sci-fi-esque for sure. If you folks have a theme for next year, let us know.
Yeah, absolutely. Let us know in chat. Let us know on LinkedIn. Anywhere you folks want to reach us out, share the feedback on the routingloop.net. We have a feedback form there, and we're super excited to be back in 2025. I can't wait for this.
Awesome. Thanks, everybody.
Thank you.